We are working on 3.5, and we're going to spend 2 days on this one. First, we need to remember how to factor quadratics. If I had x squared minus 8x plus 12, I'm going to put that in the box. X squared and 12, multiply those together, 12x squared. Are there factors of 12x squared that add to be negative 8x? Well, the 12 is positive. What does that tell me about the factors? They're either plus plus or minus minus. Right? So the middle sign is negative, which tells me they're both negative. So I'm going to have the factors of 12 would be negative 12, negative 1, and negative 12. Does that add up to be negative 8? No. The others are 2 and 6, and 3 and 4. Do any of those add up to be negative 8? Yes, negative 2 and negative 6. So I put negative 2x and negative 6x. And then I look at the top row. What does the top row have in common? X. X times what is x squared? X. And x times what is negative 2x? Negative 2. And if I pull an x out of this, I get negative 6. I end up with x minus 2 and x minus 6. Okay. So what are the roots? 2 and 6. Everybody remembers how to do that, correct? Okay, let me make it slightly more complicated. X to the third minus 5x squared minus, let's do minus 36x. There's a problem here. I can't use the box. How do I know I can't use the box? It's x to the third. How do I fix this? What do I do? Well, I look, and every term has an x. I will pull an x out of every term. And if I take an x out of here, I'm left with x squared. If I take an x out of there, I'm left with negative 5x. And if I take an x out of there, that's what I get. Everybody understand that? Now I can use the box because I have an x squared. X squared and negative 36. Multiply those together. Negative 36x squared. Are there factors of negative 36 that add to be negative 5? 1 and 36, that doesn't work. 2 and 18, that doesn't work. 3 and 12, that doesn't work. 4 and 9, if the 9 is negative, that one will work. So 4x and negative 9x. Negative 9x and 4x. What can I pull out of the first row? X. And if I take an x out of the first row, I'm left with x minus 9. And if I take an x out of the first column, I'm left with x plus 4. My factors are x, x plus 4, and x minus 9. Well, you don't want to put it back in, right? If you stick it back in, you're going to get this. So the whole point was to break it apart so that we could identify all three answers. And we know that this answer is negative 4, and this answer is 9. What is the first answer? 0. Right. So this right here tells me that one of the roots is 0. If you can pull an x out, then one of the roots is 0. Yes? Well, and flipping it works. What you're really doing is writing equals 0, and we add the 9 to the other side and get x equals 9. And the reason why I don't like the flip rule, what if our factor was 2x minus 3? You can't just flip it. you have to write equals 0. How do we get x by itself? Well, we add 3, 2x equals 3, and then divide by 2. X is 3/2. So what you're really doing is you're writing equals 0 for every factor, and then you just get x by itself. So if it's 1x plus 4, you can just flip it and get negative 4. But the flip rule is kind of weird there because there's nothing to flip. So 0, negative 4, and 9. Okay? What about this one? X squared minus 9. Can I use the box? No. Well, I guess technically you could, but we don't. This one is a special type of quadratic. We have x times x, a subtraction, and 3 times 3. So it's a difference of perfect squares. We call it a DOPS. And differences of perfect squares factor in a very easy way. It would be x plus 3 and x minus 3. My answers are just negative 3 and 3. Right? Okay. What if I had this? What does that factor into? It doesn't. Why does that one not work? It's a positive. If I tried to do x minus 4 and x plus 4, how come that doesn't work? Well, this doesn't work because 4 and negative 4 multiply to be negative 16. So what if I made them both negative? Now will it work? No, because the middle terms won't cancel. When I multiply that out, I get x squared minus 4x minus 4x plus 16. And those do not turn into 0. But when this is a plus, then the second one becomes a plus, and they cancel. So x squared plus 16 does not factor yet. Right? It will, but we're not going to worry about it today. Okay, what if I had this? X to the third minus 25x. So in this case, I need to pull out an x. X times x squared minus 25. Does it go any further than that? This one is a difference of perfect squares. X minus 5 and x plus 5. What are the roots? Well, this one gives me 0, and that one gives me 5, and this one is negative 5. Okay? All right. Let's make it just a little bit harder. X to the fourth minus 7x squared plus 6. What's wrong with this one? I'm missing an x to the third and an x, and I have an x to the fourth, which is kind of weird. But if the middle exponent is half as big as the first exponent, we can pretend that it's a quadratic. If the middle exponent is half as big as the first exponent, and the last term doesn't have an exponent, right? We have x to the fourth, x squared, and constant. If you have a constant and the middle exponent is half as big as the first exponent, we're going to use the box, even though it's not a quadratic. I draw the box, and now I put in x to the fourth and 6, and I multiply those together, and I get 6x to the fourth. Are there factors of 6 that add to be negative 7? So it's negative 1 and negative 6. But it's not really just negative 1. It's negative 1 x, normally it's negative 1x, but in this case, it's negative 1x squared and negative 6x squared. Okay, so negative 1 minus 6 is negative 7, and negative 1 times negative 6 is positive 6. I put a negative 1x squared in there and a negative 6x squared. What does the top row share? X squared. And if I pull out an x squared, what's left? X squared. And if I pull out an x squared from here, I get minus 1. And if I pull an x squared out of there, I get negative 6. So I end up with x squared minus 6 and x squared minus 1. Do those go any further? I can't take an x out. But this one is adopts. X times x minus 1 times 1. How does that factor? Do you remember? X minus 1 and x plus 1. Does the first one factor like that? No, but could we make it? What times itself is 6? It's going to be times itself. It's like 2.2. 2.2 squared is 4. Nope. 2.4. 2.5 squared. That's a little too big, so 2.45. How would we find the number that you multiply by itself and get 6? It's the square root of 6, right? What number times itself is 6? Really easy. It's just the square root of 6. So we can write x minus root 6 and x plus root 6. Right? If I had x squared minus 36, isn't that just x minus root 36 times x plus root 36? But in that case, the square root of 36 is actually 6. So, going back to this problem, what are the roots? Well, I'm going to write plus or minus 1 or plus or minus the square root of 6. Does that make sense? Okay. Yeah, because I'm lazy. Yep. All right. What about this one? Nope. Let's do minus 10x to the 4th minus 24x. You're here. Okay. What do we do here? Pull out an x. X times x to the 6th minus 10x to the 3rd minus 24. So I know one of the roots is 0. Can I use the box here? Yes. How do I know I can use the box? When this is half as big as that, you can use the box. Draw the box. X to the 6th and negative 24. Negative 24x to the 6th. It's going to be negative 6 and negative 4 don't work. Negative 6 and positive 4 don't work. So let's look. Why does negative 6 and negative 4 not work? When you multiply those together, what do you get? Positive 24. Okay. So why doesn't that work? So negative 6 plus 4 is not negative 10. So the 4 and the 6 don't work. Is there a set of factors that does work? Well, what are the factors of 24? 1 and 24, 2 and 10, 3 and 8, 4 and 6. Will one of those work? 2, oh, 2, oops. Now can you find one? Yeah, 2 and 12. And it's going to be 2x to the third and negative 12x to the third. In the first row, the top row, I pull out an x to the third, which leaves me with x to the third plus 2. And then I pull out an x to the third in the first column, and I get negative 12. So my factors are x to the third plus 2, and x to the third minus 12. Now, you don't know how to go further than that, and I'm not going to ask you to. So in that case, we would just stop. We know that one of them is 0, and I don't know what the other answers are. Okay? All right. Let's do x to the 6th minus 13 x to the 4th plus 36x squared. What should I do? Pull out an x squared, which leaves me with x to the 4th minus 13x squared plus 36. Can I use the box? Yes, the middle term is half the first term. Draw the box. X to the 4th, 36. Multiply those together. 36x to the 4th. Are there factors of 36 that add to be negative 13? Okay, what are they? Negative 9 and negative 4. Negative 9x squared and negative 4x squared. The top row shares an x squared, which leaves me with x squared minus 9, and then x squared minus 4. So my factors are x squared minus 9, and x squared minus 4. Do either of those go any further? X squared times x minus 3, x plus 3, x minus 2, and x plus 2. So what are my roots? My roots are plus or minus 2, plus or minus 3, and 0. But wait a minute, I'm supposed to have 6 answers, and I only have 5. Why am I missing one of the answers? Okay, so what is the 6th root? It's like having 2 copies of 0. Right. Right here, there are 2 x's that create 0. So you might think of it as like plus or minus 0, but plus or minus 0 is the same thing. So you could say plus or minus 2, plus or minus 3, and 2 zeros. We usually don't, though. We usually just say 0, and then we'll write with a multiplicity of 2. Multiplicity just tells you how many times a root shows up. So if 8 is a root 3 different times, we would say 8 multiplicity 3, meaning 8 is a root, and 8 is a root, and 8 is a root. Okay? And usually we don't care. Most of the time we don't care. If a root shows up more than once, we just write the root, and that's one of the answers. But sometimes we want to know how many, or what the roots are, and how many times each root shows up. And we'll deal more with that a little bit later. Okay. Let me see. Okay. Let's do one more. X to the fourth minus, we'll do, what is that going to be? So negative 33 x squared minus, no, plus 200. Can I use the box? Yes, the middle one is half as big as the first one. Wow, that's not a phone, is it? Is she cute? You're not even sure if she's cute? Oh, all right. Is she worth it? It's okay. It only hurts your grade a little bit. I draw the box. X to the fourth, 200, and then 200x to the fourth. I don't know my multiplication tables up to 200, so how do I find the factors? Just try 1, try 2, try 3, try 4, try 5. We're trying to add up to 33. If I type in 200 divided by 2, is that one going to work? 2 and 100, no. Is 3 going to work? 2 plus 0 is 2. Does 3 go into 2? No, so it's not going to work. 200 divided by 4. 4 and 50? Nope. 200 divided by 5. 5 and 40? Nope. Is 6 going to work? 6 only works if 2 and 3 both work. But 3 didn't work, so 6 doesn't work. 7 does not go into 200. 200 divided by 8, and I get 25. Is that going to work? Yes, that's actually it. Negative 8x squared and negative 25x squared. Top row shares an x squared. If I pull out an x squared from both of those, I'm left with x squared minus 8. If I pull an x squared out of the left column, I end up with x squared minus 25. That gives me x squared minus 25 and x squared minus 8. Okay. Does the first one factor? 5 and negative 5. X minus 5 and x plus 5. What if the 25 were positive? Then it would not work. It has to be a subtraction. Okay. What about the next one? It doesn't work like we used to factor it, but we're smart enough to realize, is 8 a perfect square? Kind of. The square root of 8 times the square root of 8 is 8. We're going to write x minus root 8 and x plus root 8. So my answers are plus or minus 5 and plus or minus root 8. But the book says, in addition to giving square root answers, you also need the decimal answers. How do I find the decimal for the square root of 8? Just type in your calculator, square root 8. And so that is, and we use the approximately. We don't use an equal sign in this case because it's not perfect. It's approximately 2.82. That's an estimation. It's been rounded. And actually, we're not sure what the square root of 8 equals because we can never get there. Just like we're not sure what pi equals. Pi goes on forever and never repeats. So we know a lot of pi, but we don't know all of it. So at some point, we just have to stop and say, we don't care after this point. And we call that an approximation, which is why on the wall, instead of pi equals, it's pi is close to. That's what that little squiggly equal sign means. Approximately 3.14159 and on and on and on. Okay. We are going to do 3.5. And today, all we're doing is 3 through 12 all. And then next time we meet, we'll do another set. Okay? Good luck.